Well, firstly, thank you all for um, coming to listen. And the last attempt at this back in November, or the first attempt, was pretty scary. And I appreciate your patience with me. I had a cross food allergy, and that was a pretty scary event for me. And I have since tried to discover how I can find out exactly what I'm allergic to in terms of cross foods. And I've been told by various doctors there's no way of finding out. So it's sort of Russian roulette from here on in. But, the obvious choice is just to stop eating, and which I've considered. So in any event, I appreciate all of you tuning in. I don't know how many of you have watched the videos on my webpage, so I don't want to repeat too much, but I'll just mention a couple of things for those of you that haven't. A little bit about me. I've been very fortunate. I think maybe more fortunate than most. In my childhood, I was completely fascinated with absolutely everything, certainly everything in the natural world. And my two favorite things in my life when I was very little was my white German Shepherd, a rare white Shepherd who was more human than dog, and my wind-up. And I just remember sitting there and staring at this machine and being absolutely captivated. And I somehow, at an early age, really got it. I realized this was an audio teeter-totter. This was an audio fulcrum. You had this stylus in the groove, and you had a small force. You had a large force over a small area, translating the mechanical impedance of the stylus in the groove to a small force over a large area, this megaphone. And it worked in both directions. And I thought, well, how marvelous is this? This is just, I was captivated, and certainly captivated by the natural world, and a fascination with the invisible world that supports the visible world. And that, I think that statement covers a lot of realms, both physical and spiritual. But to think about this invisible modulation in a record groove, near invisible, being translated into music, which is, as we all know, we're all here because of music. Music is like so many other art forms, a bridge from this world to other worlds, sometimes higher, sometimes lower, some modern music. But it is very powerful, and we're very porous. And I have been captivated by the concept of capturing sound ever since I tried to drag my wind-up across the floor at 3 years old. So again, I think for that reason and a few others, I've been very fortunate in doing something that I love my entire life. One of the things I want to talk about, that I've talked about in some seminars, but I want to focus a bit on it, is why analog can be so superior to digital. And there are really two things to consider. I've given a number of talks. One of them, the title of which is called Why Analog is Digital and How to Fix It. So if you think about what digital is, it's a certain number of samples per second. Of course, that's a necessarily fixed rate depending on your sample rate per second. And then there's bit resolution, which are essentially volume levels. So step levels of volume, if you will. And those are the two things that define digital. People don't tend to think about those in terms of analog, but there's a direct analog to the analog realm from the digital. One of them, and one of the soapboxes I've been on, is sampling and sample rate. So I refer to something that I'm sure no other audio manufacturer, or cartridge manufacturer rather, has the bad sense to talk about. I have plenty of bad sense, and that's, I talk about jitter. I talk about the problems with phono cartridges. So one of the problems with phono cartridges, and a major problem with phono cartridges, is that you have this cantilever with a stylus, and at the other end you have some sort of a mass. So it's either a moving magnet, or it's a moving coil, or it's a bit of iron in a magnetic field. And the problem with this system is that the energy goes up and moves the mass and it generates a voltage, but you can't get rid of all the inertial movement in this system. So in a sense, it's like a broomstick glued into a brick wall. You don't have to be Enrico Fermi to figure out what happens when you pluck the broomstick. The energy goes up and the lot goes back and the broomstick does this. Well, that's a phono cartridge. It's unavoidable. How much does it do this? Well, it's a function of a lot of things, but one of the critical things is how much mass you have at this back end storing energy. This is an energy storage system, and you cannot get rid of all the unwanted movements. There are damping systems, and they get rid of some of it, but still a lot of energy reflects back down. Why is that bad? Well, it's a surprising amount of energy that goes back down into the stylus, and you're telling this little tiny mass to get rid of the energy that's coming back down the cantilever. How does it try to get rid of it? Well, it says, all right, I'm just going to move the record. Well, no, you're not. So what's the only other option? It's to leave the groove wall and bang its way down the groove, dumping energy every time it hits. So then you may say, well, wait a minute, I don't get this. If you're telling me the stylus is not staying in intimate contact with the groove wall, how can it make music? How can it reproduce sound? That's because what it's doing is it's sampling. And since magnetic systems, magnetic transducers are velocity sensitive devices, they will produce a voltage or a signal as long as they are moving. And those of us that had that generator on the front wheel of their bike when they were kids noticed that when they went faster, the headlight got brighter. That's a velocity generator. The faster it goes, the more voltage it produces. So even though the stylus is only sampling the groove wall, it is still generating a waveform of sorts because it is taking samples. So then the question is, well, how good is that sampling? And the answer is, we've all lived with it up till now, but what happens if you do something better? So I was very fortunate in striking a deal with Bang & Olufsen nearly, now it's almost 30 years ago. I was very enamored with their design. It was a moving iron design. And there were many advantages to the design. One of the big advantages was a dramatic reduction of moving mass, internal moving mass, so therefore less reflected energy and less jitter. Bang & Olufsen did a white paper in the 60s. It was quite fascinating because they showed the comparison between then the emergence of moving coil cartridges, these wonderful cartridges, and their design, the moving cross. And they showed an evolution over the next 20 years as they reduced the mass and improved the magnetic field, how it was going to stay well ahead of moving coil cartridges. This fact in this paper was lost, I think, on a lot of people, but there were some audiophiles who realized that the Bang & Olufsen design was a wonderful cartridge, and they were wonderful designs. The B&O used to actually sell their cartridges with adapters for standard half-inch mount. Certainly the cartridge and the design was adapted to be user-friendly because it was a plug-and-play cartridge. And so some compromises were made. But over a period of about 30 years, Bang & Olufsen made 3 different generational changes, improving the cartridge kind of each time as they reduced the size of the cartridge to their last series. They stopped producing in '86. We picked up manufacture in 1990. One of my joys in getting the license agreement with Bang & Olufsen was that I knew I could produce some half-inch cartridges and continue to evolve the design. Other designs had really reached their limit. They were sort of like a Nautilus, but they weren't as well perfected as nature had done with the Nautilus. It was almost like the Ford Edsel, and then the world ran out of gasoline, and then 30 years later we found a bunch of gasoline, and everyone went back to making Edsels again. You know, people that make moving coils were all tooled up, and hey, we've always done it this way. There are some interesting things. You know, there are not many measurements that you can do in audio that reveal much about a cartridge. I'm going to try and do a screen share here. Actually, I want to, just before I do that, I want to bear with me for just a moment. I just want to put this up. Okay, this is an article. Can you all see this? Can anyone see this? No?
Yes,
Mark,
Yes.
you want to give me?
we can see it, Peter. 20
Okay.
hertz signal, etc.
Yeah, okay. All right. So I'm not going to read this top part. This was done by an Audiophile engineer, and it's quite wonderful, but it kind of bothered me because it's not that I'm into sports, but it's like a football player taking, being past the football, and he runs downfield and he stops at the 2-yard line and looks around to see who's coming. They did this wonderful bit of engineering and stopped short of the real conclusion. So what I want to do is go down here, and part of it's being occluded by the images. There we go. Let's see if I can do this. All right, so this says the displacement of a 10 kilohertz signal, 50 dB below a peak, or the loudest thing you record, displaces the groove 0.005 microns, 50 times the diameter of some small hydrocarbon molecules. And it goes on, it says the scale is almost impossible to grasp intuitively, but a cartridge can trace it, and the signal, when amplified, can easily be heard. Certainly any vibrations in the record playing system significantly better than 0.005 micron can be expected to distort the cleanliness of low-level, high-frequency reproductions. So a designer must absolutely control all spurious vibrations, be they generated by the commonly considered external sources, feedback, footfalls, internal mechanical sources, the arm bearing, or the crucial, here it is, groove stylus energy interface itself. So I found that absolutely incredible. Now I'm going to get off the jitter thing for a moment. I'll move back to it in a minute. And I started thinking, well, okay, if a medium grade cartridge can detect 50 small hydrocarbon molecules, a really well-made arm and a really good cartridge, let's say 20. So I looked up the diameter of a benzene molecule, and I started doing some math. And it turns out that the step resolution of analog, when it's done right, now I'm not sampling now, this is level resolution, is 200 to 500 times better than 24-bit digital. That blew me away when I did the math. So now let's talk about jitter. And I'm going to go back and do a screen share. So this is a relatively large, forget the cantilever for the moment. This is on the left is a relatively large relatively small moving coil assembly. It's wires wound on an iron core on the end of a cantilever. This is our largest moving iron assembly. This is the largest one we make. In our Hyperion, it is much, much smaller. So the moving mass inside our design is 5 to 8 times lower than even a small moving coil design. I want to see if I can pull up something else. Bear with me for just a moment.
How are you able to accomplish this smaller size versus the typical moving coil?
It's the design. This is a moving iron design. So the way the moving iron works is that you have a small amount of iron moving inside of a magnetic field. The coils are fixed, so there's no moving wires. And to the coil assemblies, it looks like you're moving the magnet, but you're not moving the magnet. You're varying the magnetic field as if you were moving the magnet, because you're moving an interposing piece of iron, a very, very tiny piece of iron. All right, let's try this. Okay, can you all see that?
You give it a second. There you go. We're good.
Okay, so this gives you again, what I was talking about is that what happens with the mass inside of a cartridge. You have, with a moving coil or a moving magnet, a relatively large amount of mass, and with our moving iron system, much smaller mass. This gives you a relative amount of the reflected energies. Something else happens as well. Not just the amplitude or the amount of the reflected energy, it's also the frequency of the reflected energy. A typical moving coil cartridge, the natural resonant frequencies, there are two kinds of reflected energy. One is the broomstick thing I mentioned, and the other is the natural resonant energy. This is from having a sprung piece of mass, a mass on the end of a spring. There's a damping system, and you have a sprung cantilever. The resonant frequencies, the spectrum, is dependent on how much mass there is and how tightly it's held. With a moving coil cartridge, you have a spectrum between 30 and 50 kilohertz, and it's very loud. So you would say, well, that's not a problem. That's above human hearing. Well, it is a problem, because if you take a 30 and a 40 kilohertz resonance and mix them together, or they're both happening at once, you get a sum and difference. You get a 70 plus you get a 10. And that's at the top of the audio band. If I ask people what they think causes groove noise, they will invariably say, well, it comes from dragging a diamond rock through a plastic groove. Interestingly, well, that's logical. That's not the right answer. Groove noise is caused by jitter, what I talked about at the beginning of the talk. It's caused by this resonant frequency and jitter. This creates harmonics up in the top of the band between 7 and 8 kilohertz and 20 kilohertz. And it sounds like white noise, or what we call groove noise. You reduce the moving mass, you move the resonant frequency way the heck up, even though it can beat still and get down into the top of the audio band. The result is much lower groove noise, much lower groove noise, because what's happening is you are not generating the kind of energies going back into the stylus. But the real positive thing is your sample rate. Your sample rate goes way up. And that's what makes a huge difference in cartridge design. How much stylus jitter do you have? Now, I want to show something else, because I mentioned a moment ago that I said, it's very, very difficult to, take any measurement in audio that's really quite meaningful, that has a direct significance. And forgive me, I'm going to try and change this picture because I'm having trouble selecting the other one. I've changed it. Can you all see this?
Yes.
Yes.
Okay.
Mhm.
So I want you to consider this. When I worked at Bozak, Rudy Bozak once came into the lab, and I was designing a full range 6-inch driver for a miniature speaker I designed in the 70s called the MB80. And Rudy came up and he said, have you tried the strobe on your new driver design? And I said, no. And he went and found the strobe, and we plugged it in, and we drove the speaker on the workbench there at around 60 hertz. And he took a strobe and tuned it to 60 hertz. And I saw something that was startling. The cone was not just moving in and out. The cone was, you could freeze, of course, the motion of the cone, but the cone was pitching and yawing as it was moving in and out. And I looked at him and he said, that's reflected energy, and it becomes rotational energy. It was a heck of a lesson for a young engineer. And this is what happens in a cartridge, because the energy just doesn't go up and down. It actually rotates around the cantilever as it goes up and down. Now, what does that mean? Well, if you look down here at the bottom left, if we take a groove that has modulation on the left channel and no modulation on the right channel, what you're asking the stylus to do is move this way, but you're asking it to slide up and down this groove wall without moving this way. If it moves this way, it creates a signal in the other channel. It'll create a right channel signal. How do we measure it? Very simply, it's called crosstalk. And if you look at the crosstalk of most cartridges, a good cartridge will be around 25 to 28 dB, 30. Very good cartridge will be somewhere between 30 and 35, a very good cartridge. Our cartridges measure between 35 typically and 45. A number of the Hyperions and other ones I built, the Pauas, they measure up. I built a few the other day. They were up in the 50s, low 50s. I don't know what I'm measuring. I'm maybe measuring the limit of my test record, the limit of a Neumann lathe that cut it. What this does, though, is it tells you how much jitter is happening, how much reflected energy and resonant energy is going back down the cantilever. If you have a lot of it, you're going to get a lot of jitter, and you won't have a good crosstalk figure. So then it begs the question, well, does it always mean a wonderful cartridge? You're getting great sample rate. You're taking a huge number of samples per second. No, there is a way to cheat. In a moving coil cartridge, what I've shown here, it has a suspension wire yanking this coil back into the damper. I've repaired tens of thousands of moving coil cartridges over a wonderful number of years. I can promise you that if you yank this wire back, you will damp the heck out of this moving coil structure, and you will reduce the jitter. You will reduce some of this reflected energy, or even the resonant energy that makes it back down the cantilever. What does that cartridge sound like? You really don't want to own it. So when they make a moving coil, it's a compromise between how loosely to bond or to pull this coil structure into the damper. It's a compromise, like a suspension on a car driving down a bumpy road. You want to get rid of a lot of the bumps, but you don't want to make it too soft. You want a nice ride. Well, that's what you want with a cartridge. How do you improve the situation? Get rid of as much of this mass as possible. And again, channel separation is a really interesting way of measuring this. So there are two important issues here: the sample rate of the stylus, and again, it's going to vary. Unlike digital, which has a constant sample rate of whatever, the stylus is going to have a different sample rate depending on the frequency, depending on the complexity of the momentary, waveforms that are there. All of that creates resonances and causes jitter. So the jitter, or the sample rate, is by no means a constant. But if the cartridge is designed really well on some very sound principles, and the tone arm is doing a really wonderful job, the jitter can be reduced quite dramatically. And those of you who are vinylophiles and audiophiles and analog for a long time, when you hear it and it's right, there's something in you that absolutely knows it. But I love the Audiophile statement that mathematically translates to a 200 to 500 times improvement in step resolution, because that's actually quite dramatic. So certainly there are moments with sampling where analog is going to be digital, and vice versa. There are going to be moments where digital sampling, especially if it's high speed, is going to be really, really good. So we know that the analog sampling is variable, but the bottom line is, how do you build a cartridge and minimize the jitter? Two things that we've done other than acquire a design that has extremely low moving mass is to have a breakthrough in cantilever design. The real life of an engineer is that you never get to perfect anything. That's an illusion. Nobody has that luxury. I mean, bridges and airplanes are built 10 times better than they need to be, so they generally don't fall down. But in engineering, you've got a boss breathing down your neck, or if you're a small company, you've got a pile of bills and maybe employees to pay, and you're thinking, I better make this darn work and bring it to market. So it's always a lot of pressure. In audio, of course, it's probably greater because it's a smaller industry. So it's not like one of these big industries. You're an engineer working for a very large company. So things are made to work. And once they work, we're happy. The engineer's happy. He's selling product and everything's fine. But there are dark corners in engineering where things have been made to work, but they've certainly not been perfected. And one of those things is cantilevers. So years ago, I sat with an engineer who was like a brother to me. I worked with him at IBM Research, and a brilliant physicist. And we were just chatting about how to improve cantilevers. And we went through a list of cantilever materials. And one of them that was mentioned was cactus spines. And we wrote it down. Well, 10 years later, Frank Schroeder, the famous tone arm designer, gave me a call and very diplomatically said to me, Peter, what's on your engineering research list for cantilever materials? And I said, let me pull it up. And I got down to the third one and I said, cactus spines. And he said, stop, where are you with that project? And I said, like 150 other inventions and projects, it's on the back burner. He said, in his best strengthened German accent, he said, moves this up to the front burner. And I said, why? And he said, because I've just put some in the mail to you. So who knew that among the myriad of talents and interests that Frank has, and they are vast and wide, and I will never know all of them, he's a cactus aficionado. So when the spines arrived, I put them under a microscope and I dissected them. And had I not been so circumferentially challenged, I really would have kicked myself because what I saw was really remarkable. What I saw was stacked columnar cells filled with desiccated resin, wrapped with a fibrous bundle. And a whole bunch of these things were strapped together and tapered down to the end. And I looked at it and I thought, man, this thing is just gorgeous. It's just gorgeous. So I figured out how to affix a diamond built a cartridge with it. Now there is a test you can do with a cartridge that's very revealing. It's what the Audiophile test record has a pulse test. So it's a 1 millisecond pulse. So it comes along and does this. Because of the reflected energy and the stored energy in a cartridge, when you play it and look at it with an oscilloscope, you see the 1 millisecond pulse. With a moving coil, you see about 3 or 4, maybe 5 big rings, depending on the design, and a bunch of little ones. With my then best, my Cicero moving iron, it went up and down, and it had 2 small rings, and then went flat. When I built the first cactus spine cartridge, it went up and down and flat. And I said, all right, this thing's overdamped. Let me do a frequency response test. Did a response, it went all the way out. And I went, holy crap. So then I listened to it, and it was stunning. And I realized that nature had designed the world's near perfect cantilever structure. You know, we had done our best with aluminum alloys and boron and ceramics and, you know, ruby, sapphire, same material, diamond, you know, all kinds of things. And they were good in some respects. Some had better damping, some had greater rigidity. But the cactus spine was the best of all possible worlds. And the resulting measurement and listening really proved that this was a dark corner that I was able to shed some light on and make a real breakthrough in cartridge design, not just something for marketing. The other thing, of course, is the strain gauge, designed by Sal Wynn in the late 60s. And I was introduced to it by Richard Majestic, who I worked for at Ram Audio in the 70s. And I remember the first time hearing one, and I was, you're just shellacked, you're just overwhelmed. The strain gauge had a hard time getting hold. There were people that loved it, but it was so revealing that it's like getting too close to a really beautiful woman. I mean, you want to back up about 5 feet, maybe 10 feet. So some recordings, you really don't want to play them with the strain gauge, but others that were done well, good Lord, really an amazing experience. So when I left Ram Audio, I looked into how to manufacture these, and I did slowly manufacture them for friends. And then about, now it's probably 12 years ago, I decided to make a commercial unit. The beauty of the strain gauge is that the mass that's normally here at the back end of the cantilever is gone. It's simply not there. There's no stored energy to reflect. And if you terminate it correctly, what you get is energy going up and dissipating, which is much easier to do when there's little or no mass. So there's no reflected energy. One of the empirical bits of proof of that is that for those of you that know what a lacquer is, this is something you cut on a Neumann lathe. I have 2 Neumann lathes I use for a charity project called Direct Grace Records. We rescue children from severe forms of slave labor. So we cut direct to disc and half speed. When you cut a 12-inch dub, normally when you make a record, you cut a 14-inch lacquer because you use the outer inch for testing your cut. But when you're just cutting to see how the lathe's doing, or you're cutting something to send to someone to play, you cut a 12-inch lacquer. The lacquers are playable about 3 or 4 or 5 times, even with the best cartridge. Even my magnetic cartridges, with the Hyperion, after about 6 or 7 plays, the groove gets a constant noise in it, and the high frequencies get stripped out. The material is so soft. When you play with the strain gauge, it's not damaged. This is tracking at 2.3 grams. So it begs the question, well, what's going on? What's going on between the stylus and the groove interface that it's not taking this thing that's just this side of butter in terms of hardness, and why isn't it ruining it? I have lacquers I've played over 200 times. There's no noise. All the high frequencies are there. What's going on? Well, it's really quite fascinating. What's going on is, since you've eliminated the jitter, you've eliminated the groove damage. You're not recording noise into the groove wall. You're not using it like a cutting stylus. The strain gauge is the only cartridge I'm aware of in the world that will play a lacquer hundreds of times without damage. Tam Henderson of Reference Recordings uses one, and others do, to play lacquers. It is really quite fascinating. You know, the other thing I've seen, and I can't advertise it because I've not done enough empirical research, but I had a gentleman in Hawaii who bought a strain gauge. He had owned some moving coil cartridges, and they very expensive ones, and they lasted about a year. each. And he called me up and said, can you fix them? And I said, what do you have? And he said, two such and such cartridges are about $5,000. And I said, what's wrong? He said, the channels are dead. I said, how old are they? He said, about a year. I thought for a minute. I said, how far are you from the ocean? He said, about 100 yards. I said, no, I can't fix them. But he bought a strain gauge, and he has now owned it for about 8 or 9 years. I kept telling him, you've got to send it in. The style I have to be worn, let me look at it. No, it sounds fine. I said, I know it sounds fine, but you need to send it in. After 6 years, he sent it in, and the style he'd been using only had about 15% wear, and it easily had over 6,000 hours on it. So that begs another question. Why, all he did was play records all day and work at his computer. And it begged the question, why is there such little wear on the stylus? So if you realize if you've got a brand new set of tires and you've had too much to drink and you're banging off the curb, you're not going to get 30,000 miles out of those tires. When you hit the curb, you're going to do a lot of wear and sudden damage. When the stylus is banging, constantly jittering, you have moments of high force. If you get rid of the jitter, then you don't have moments of high force. You just have a relatively constant force, and the wear factor goes way down. So it was a really interesting experience. So fortunately, over the many years, moving coil cartridges have improved and gotten better and better and better sounding. And the strain gauge, it became something that people could actually listen to for the most part and really enjoy. When I play it for a room of 30 people, there's usually about 10% that really don't care for it at all. And the others really love it. They say we don't have acoustic memory, but we kind of do in a way. We know what we expect something to sound like. And a lot of what people call break-in, component break-in, I'm going to attribute to brain break-in. I mean, those of us who are married know you can get used to almost anything eventually. So, music is so wonderful. I just really think that there's a lot going on psychologically and physiologically. After you've listened to something for 10, 20, 30, 40 hours, it becomes part of you, like, a pet or a spouse. So certainly there are break-in things and there are features, mechanical and electrical, that go on with equipment and electromechanical systems. But a lot of break-in happens up here. So fortunately, the strain gauge has become listenable over the years. And I'm glad, because I occasionally sell some. It also has use of replaceable styli, which is a real plus for a high-end system. So I'm not going to talk too much more. I've really talked about a number of the things I wanted to talk about. I've talked about sample rate. I've talked about step level. I've talked about some of the problems with phono cartridges and what we've tried to do to resolve them. And it's a joy beyond consideration. When you build something so small, the science and engineering only goes to a certain level. And beyond that, it's intuition and luck and experimentation and practice. Because you can't, at a certain scale, you can't imagine everything. What's the difference between a Hyperion that I make that measures 53 dB of channel separation and the next one I make that measures 40 or 42? If I look at it, I can't see a difference. It's not, and that's true of the Cicero and it's true of the Paua generally. Is it the glue joints? Is it the orientation of the parts? Is it, at a certain point, it's near invisible? So it's a joy to make something so small that works well and that are fun to build and fun to rebuild, because we rebuild all of our products. That's kind of it for the moment. I'd really love to open up the floor for questions.
Hey, Peter, when you do end up with a 40 versus a 53, do you do anything to that 40 to?
I sell it.
And when you
don't look back.
When you rebuild cartridges, do you do any tinkering with the suspension and all the other stuff that
I've made a lot of improvements. I've made a lot of improvements to the basic design since we started. So if I take apart, let's say, an old Zephyr cartridge, a VPI Zephyr, or an old AIDA or an old voice cartridge, and I see there are suspension changes we've made for improvements, I will make those improvements. It's not just replace the snap cantilever and missing stylus. I will open them up and have a good look around, see how it's aging. You know, cartridges age at different rates. You know, rebuilding as many moving coil cartridges as I have done and do, it's a little disheartening. You know, when I spoke with Sal Wynn years ago, he told me about where he got the elastomers to play with for the strain gauge. The strain gauge is, by the way, notoriously difficult to build. There's a lot of high English that goes on when I'm making them. Fortunately, over many years, I figured out how to make them reliably and consistently and make them stable. But it is so much different than a magnetic cartridge. You build a magnetic cartridge, it will work when you get done. It's just a question of how well. If you build a strain gauge and you don't do everything perfectly, it will not work well at all. So they're very challenging to build. When Sal Wynn was developing them, he had the option of using a lot of NASA's elastomerics. And that was a real plus because everything about an elastomeric has a huge effect on the performance of a phono cartridge. You're depending on that elastomeric for structural support and damping. So it's not a elastic, it's actually a viscoelastic. And the problem with viscoelastics or elastics is that they change with time. They outgas. I mean, any one of you has reached for a pencil in your top drawer and take it out and the pencil's turned to stone, the eraser's turned to stone, knows what I'm talking about. Or you've gone into a drawer where you had rubber bands holding something together and the rubber band's gone, except for these little hard brown pieces sitting at the bottom of the drawer. Elastomerics change molecularly. They change. They outgas. The chemicals change. Some are more stable. I've worked on moving coil cartridges that are 40 years old, and the elastomers are like the day they were made. Conversely, no names mentioned because I don't ever mention a brand name, positive or negative. It's just inappropriate as a manufacturer. I've seen some moving coil cartridges that are a year, year and a half old, and the elastomers have cracked and turned to stone. When I was at IBM, there are accelerated tests that you can do to various materials. I doubt that cartridge manufacturers, maybe especially small ones, take the trouble to do those tests. They find a material that works well, it measures well, it listens well, and they go, good, sort of like a cantilever that works. And a couple of 2-3 years later, when that cartridge is falling apart, you know, they don't feel maybe terribly responsible. I don't build stuff with materials that I know don't last. So I've done a huge amount of research into the elastomers that I use to make sure they will last 20 or 30 years. That is very critical to me. If I'll find an elastomer that works better, but I don't know enough about it, I will not use it. I stick with materials that are tried and true and that I know are going to last through the test of time.
Oh,
did I answer your...
Sorry, Mark. I just want to follow with Peter. The question I was asking you about doing other work in cartridges, I was actually wondering if you do that with the non-Soundsmith cartridges that you're rebuilding.
Absolutely, absolutely. And again, I'm not going to mention, let's see, are these people in business? Is Aikida still in business?
I don't think so.
I don't think so. So Aikida made a number of cartridges and they tried to mimic the principle of cutting head. So let me put it this way. There are a number of the Aikida cartridges that oscillate at 1 kilohertz. So you put them on the record and you can record on vinyl a really nice tone, a whistle on your record. The mechanism has changed. The resonant characteristics of the material, the Young's modulus, the viscoelastic nature, everything's shifted. So instead of being damped, it actually goes into violent resonance and cuts a tone on your vinyl record. So that's an extreme example. So what do I do when I see one of those cartridges come in? They're a challenge to rebuild. The diamond is mounted to this tiny little horizontal piece, which is glued to these coils that are in the air that are damped. I modify them. I figured out how to modify them to stop them from resonating so they will at least play a record. So do I modify a lot of moving coil cartridges that I know have inherent problems, or can I fix one that has where the elastomer and the damping material has changed and it's just not being damped or suspended properly. Sure, we do it all the time. We make an effort to allow people to continue to extract some money out of the products they've spent a lot of money on. And if we do a good job, they'll get a lot of other additional years, out of the new stylus we put on it, and they'll enjoy it. And it's not all about money. It's really about, I've taught. Soundsmith has been a mentoring company for 50 years. I saw audio dying in the 60s. I saw what was happening with new electronic fields, medical electronics, avionics, the digital age, on and on and on. The Japanese doing really well. The American audio industry sort of dying, and I wanted to do something for the industry that I loved. So creating Soundsmith as a mentoring company has really been my biggest joy. Fitting people for jobs, often in the industry. Jeff Joseph, who's on, his mother used to drop him off for lessons at my house. That's my greatest joy. When you mentor in a field, it's really a great way to learn. I worked at IBM Research where there were 3,000 scientists and engineers, and those are very unique people. Those are people that can study and get a degree in something and then apply it years later like this. It's right there. Other people aren't built like that. A lot of other people, myself included, can't learn things until they have a need to know them. So my methodology for 50 years has always been to walk somebody over to the deep end of the pool, usually unwittingly on their part, and hand them 50 pounds of lead weights and push them in. And it's remarkable what happens. I wish I had videos. But when you're faced with a problem you have to solve, when you have to repair something that's failed, and everything that's made by man has weak links, when you have to re-engineer a weak link in the design in a very narrow set of constraints, that's great engineering. That's when you learn how to be clever. That's when you learn how to apply your intuition and really think. And that's a great way to teach engineering, I think, for those who can't learn by the standard formal method. And there are plenty of those. And that's how I've taught. So yes, when I take a moving coil cartridge and I think I can improve it, sure, I will do that, because I'm not just giving the customer something better. I'm learning something and I'm experimenting and I'm thinking. And I just want to add a statement to that, which really blew me away, that I found recently. Ralph Gomery, Dr. Gomery, was head of IBM Research. He was head of all 5 IBM Research divisions. And for some reason, he parked next to me every morning. And when I invented this thing at IBM, a new way to package silicon, was presented to him. And this man had an incredible memory. He went and shook my hand when I was a new employee there, came in the lab. I didn't know who he was. And years later, when my work was presented to him by my second level manager, he saw my name on the foil and he went, Ledermann, used to be an audio designer, engineer, a thinker. Yeah, good man. I'm going to come to the lab and see his work. And my second line manager said, how the hell does Ralph Gomery know who you are? And I said, I met him when I started here years ago. He somehow looked at my background and introduced himself to all the new employees. That was the old IBM. So I read a recent article by Dr. Gomery, still alive, he's in his 90s. And it turns out he's one of the world's finest economists. And he made a statement that's seemingly so simple, but really beautiful. I don't know if any of you know who Amory Lovins is, but I fortunately got to meet him. He's with the Aspen Institute. He's one of the brightest people in the world. And he made a statement. He said, an unobvious truth requires a tremendous amount of energy to hide. But an obvious truth is easily hidden by public incredulity. And I was blown away. An obvious truth is easily hidden by public incredulity. So I'm reading the statement that Ralph Gomery made, and he said, when you outsource, when this nation outsourced, we gave away our ability to innovate. Whoa. When you don't have the problem right in front of you, you're not thinking. When we outsource, we give away the opportunity to innovate. It's a seemingly simple statement. It's an obvious truth that's been easily hidden by public incredulity. So I've had a deep love of science and the natural world and how things work and invention. So having things in front of me has been my teacher my whole life. And that's what I've done to people who've come in and worked with me. That's how I've taught them. I take them over to the deep end of the pool and throw them in, hand them some lead weights and throw them in. So it's a long answer to, do I modify other people's cartridges? You bet, you bet. Seems like the right thing to do.
Thank you. And we'll take some questions. I've got 3 hands up in the air now. Alan Edelstein, Jonathan T, and Rick Beckers in that order. So Alan, you want to ask your question?
Am I unmuted?
Yes.
You've been talking about cantilevers and suspensions, and there's one that's been around for a long time that doesn't fit the regular definitions. Can you talk about the Deca cartridge at all?
Yeah, so again, I have a bit of a problem talking about products that are in existence, but I can talk a little bit about it, and hopefully I won't get into too much trouble. But it is part of my audio faith tradition not to say anything positive or negative, but I will talk about it from a theoretical standpoint. So you've said it doesn't have a suspension. That's totally wrong.
Well, I meant the standard rubber suspension.
It does. It has one.
I thought it's for a damper at the end.
It has a damper. It has a damper. You're correct. It's a damper, but that's what the rubber does in a moving coil cartridge. It's essentially damping. It's a little bit suspending. A moving coil is a wire suspension typically, but the donut that's there is primarily for damping. The London does have a damper. You know, people call it a cantileverless cartridge. That's completely untrue. In a standard cartridge, what you have is the hypotenuse of the triangle. In the London Deca, you have a vertical cantilever and a horizontal cantilever, and it's pinned at the back end, and then there's a rubber damper on it. So you have this stylus that's moving up and down, but it is hooked up. It's hooked to a cantilever. It's just vertical. And then you've got a horizontal cantilever that's doing this. So let's talk about that in terms of moving mass. Is it less moving mass or more moving mass? It's a ton of moving mass. Why do people like them? Well, let's think about the ski jump. You're coming down the ski jump and you get towards the bottom. You've got all this downward, you've got a forward vector and a downward vector. You're coming down the ski jump, and what happens at the bottom of the ski jump? It levels out. So you're pressed down really hard on your skis before you're launched, and then you hope the angels pick you up and float you down somewhere. That's a London cartridge, because what happens is when you get a groove modulation that's pushing up, because of the high mass, you've got a lot of force between the tip and the groove wall. But when the groove wall moves in, that's off the end of the ski jump. And then there's not a lot of contact pressure between the stylus and the groove wall. Let me mention something, not briefly, that's connected with that. Stylus shape, very complex subject. When you have a conical, sorry, I'm allergic to them. When you have a conical stylus, you have a very tiny circular area touching the groove wall. When you have an elliptical, it turns into a bit of an ellipse. When you have a contact line, a very long ellipse, and more esoteric ones. Here's something to think about. If you have a cartridge tracking at 2 grams, it's 1 gram per groove wall, and you've got 1 gram of force on a little tiny circle on a conical, you get what's called a lot of tip damping because your force per unit area is really high. It's a difference between you sitting on a bicycle with racing tires or you sitting on another bicycle with mountain bike tires that are wide. The force per unit area on those narrow racing tires is really, really high. So the force per unit area with a conical stylus is really high. So the jittering that would normally happen is reduced because of this high force per unit area. When you start going to an elliptical and a contact line is double the surface area of a conical. The force per unit area is down by half, so you don't get as much tip damping. So you think, well, gee, I'll put a really nice high-end stylus on this cartridge design, it's going to be better. No, it won't. All that's going to do is give you better high frequency tracing at the inner grooves, but it's not going to give you better tip damping. It's going to give you worse tip damping. So I'm relating that to the Decca, where you have high tip damping because of high inertial mass when the modulation of the groove is positive, but when it's negative, you get the opposite effect. Something people don't think about with the Decca, but that's why they like it. They really like it half the time.
Jonathan T, you want to take it?
Yeah, I have like two questions that are completely unrelated. Number one, I noticed on your webpage that you were having a lot of problems during the pandemic, so I kind of held back on sending in cartridges for retipping. How are you guys doing now? Do you have like a huge backlog, or are you almost caught up?
What kind of a cartridge?
I have like a Vanden Hall, a Benz, a couple Dynavectors.
We're probably running about 3 weeks right now. We're really, really good on those.
Oh, okay. That's very good to hear. I thought people might have sent in a zillion while you were not operating at all, and you'd be like 6 months behind.
Yeah, well, I mean, some parts are 6 months behind. You know, I'm still not 100%. So even though I'm not supposed to be working full time, I'm back to working 7 days a week. And, you know, a lot of my work, personal work, is very backed up, but other work we've caught up, and we're doing pretty well. So
Okay, part two
thank
of the
you.
question. Many people say that when you retip a cartridge, it sounds a little bit different than it did before when it was like brand new from the manufacturer.
Yeah, it often sounds better.
Interesting.
Yeah.
Do you
What
think
would happen-
cartridges have like distinctive sounds that are like particular to their house brand?
Say that again.
Do you think that various manufacturers of cartridges have specific sounds that are like native to their brand and what they're trying to do?
Okay, so I'm going to separate what they're trying to do. Different designs have different sounds. Whether it's intentional or not, I can't comment on. But certainly different designs have very different sounds. And that's true with a lot of audio products, especially transducers, microphones, loudspeakers, phono cartridges, because they're the most difficult parts in a sense to make. You know, audio products have a certain amount of their DNA in the camp of musical instruments and a certain amount in scientific instruments. Electronics, a little more, they have much more of their DNA in scientific instruments than musical instruments. Phono cartridges, microphones, loudspeakers, they have a lot more of their DNA in the camp of musical instruments. If that weren't true, they would all sound the same, and they don't. So whether manufacturers want to get a particular sound or the engineer goes, man, it works, let's market it. And they weren't thinking about how it sounded necessarily down to the last detail. I can't answer for somebody else. I can certainly tell you that as a manufacturer, we've run into some bottlenecks and engineering problems. And when we get them solved, it's like, let's fill orders. That's just the reality of things.
How many people are retipping at Soundsmith these days?
We have a number of them doing it now. And I've just hired 3 more people. So, you know, the company has grown, and I think we've become a lot more visible. And our reputation seems to be pretty solid, and people trust us. You know, we stand by our products, we stand by our customers, and we tend to, you know, treat them very well. I've often wanted to do a business card that says, with a new byline that says, Soundsmith, we bend over backwards for our customers. We already tried bending over forwards.
Harry, you wanted to chime in?
Yeah, I just want to add a couple of items here, which Peter graciously hasn't said. The strain gauge, I have 11 phono sections. Okay.
I love dogs.
I have 11 phono sections. Every one of them registers on my digital recorder.
Who has the dog? Can somebody mute who has the dog?
Jerry.
Jerry.
I muted Jerry. It's not him.
Well, it's not me.
All right, we're good.
Okay. yeah,
Everyone
Harry, go ahead.
registers on my digital recorder except for the strain gauge. That's 60 dB down. The audio research, the PS audio, the Levinson, blah, blah, it goes on and on and on and on. The strain gauge recorded 0 on the VU meter. It was beyond 60 dB down in Phono.
Yep.
That's
one of the,
incredible. I've never seen that before.
I appreciate that, Harry. It's the strain gauges. There are a lot of real big positive things about it. One of them is the blackness, is the signal and noise.
Yeah.
There's no cartridge in the world that has the signal and noise level of the strain gauge. It is.
I recorded the Fala 3-cornered hat from Sid Marx's original Decca, an original. The thing looked like it was never played. And the dynamic range on this thing is frightening, literally frightening, using your cartridge. I'm not selling Peter's cartridges. I'm just saying, if you need anything, this man knows how to make a cartridge.
Well, I appreciate that, Harry. Thank you so much. You know,
My pleasure.
I wrote an ad, which I think we're still running it, for the Zephyr Mimic Star, which is a very good seller.
Yeah.
I'm trying to remember what the ad said. It's sort of like details, 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 and underneath it says the devil's address. You know, it's kind of a funny ad. The devil is in the details. You know, you can build a magnetic cartridge and it'll work, but to get something to really superb, it really is in the details. You know, you can build a violin, but it ain't going to be a Stradivarius. Really and truly, when you're building a transducer, the devil is totally in the details. And I'm fortunate enough to have lived long enough and had the advantage of taking apart, I don't know how many tens of thousands of cartridges, and seen it done right and seen it done wrong. So it gives you a certain level of intuition and understanding, and you know, and a lot of, you know, what is the quote? 99, you know, invention is 2% inspiration and 98% perspiration.
Right.
That's absolutely true. I mean, you do sweat bullets, but you wake up in the middle of the night and you think, I know how to fix that. You know, one of the things I fixed on the strain gauge, which has been bad from its inception, is the velocity performance. My magnetic cartridges, like the Hyperion, that has a ridiculous velocity performance. It's 90 centimeters. It's crazy. You just cannot get the thing to leave the groove. The strain gauge, the original ones, all the way through the Panasonic, the Machistas, and so on, the Win, they're down around 25 to 28. My original strain gauge was around 28 to 30. I've recently got it up to about 40, 41. And that was, for me, a big, big breakthrough. You know, I wanted to make sure it would handle a direct-to-disc with some overmodulation without leaving the groove wall. It was a big issue with the strain gauge from its inception, and it took me a lot of years to figure out, okay, I know what to do now. I know what to do.
So I accidentally lowered Rick Becker's hand. I was getting a little carried away with myself, getting the hands lowered. So Rick is next, and then we'll get to Jonathan Scull and Bruce Barber. So Rick, you want to unmute yourself and talk?
Yeah, hi, Peter.
Hi, I'm going to grab a drink. You can keep talking. I'm just going to grab something to drink.
Okay. I was intrigued with the photo of the moving iron and the moving coil cartridges side by side there. And it raised the question in my mind about how the different materials used, say, in a moving coil impact it versus the moving iron.
Okay, when you say the different materials, what materials are you referring to?
Well, the stylus there primarily, yeah.
Okay, so the styli really don't have a bearing. I'm sorry, I apologize. I'm not following you.
Well, the styli on a moving coil can be any number of different materials there. You know, boron or diamond or
the cantilever.
Like
sure.
Cantilever. Sure. I'm sorry. The
That's
cantilever.
Right.
Yeah.
Yeah.
And the And on the moving iron, you've got an iron.
No, no, I'm sorry if I confused you.
Oh,
I
okay.
apologize. The cantilever materials that we use on our moving iron cartridges are very similar, if not identical, to many that are used with moving coil. What's different is the generating element itself. So inside the cartridge, that's affixed to the end of the cantilever. So there are three kinds of basic magnetic cartridges. One where you have a magnet back here, which is moving near fixed coils. The other is where you have a coil structure moving in a magnetic field, and that's generating a voltage. Anytime you move a conductor in a magnetic field, you get a flow of electrons. The third kind that we make, it has a fixed magnet and fixed coils. And the cantilever has a tiny piece of iron that tips. And what it does is, if these are the coils, as this iron tips, it makes it look like you're moving the magnet, this big massive magnet, but you're not. You're just varying the magnetic field. So the beauty of that is you're able to dramatically reduce the moving mass by having a system that neither moves the magnet or moves the coil.
So the iron on the moving iron is just at the tip of the cantilever.
It's at the inside, correct. It's at the inside end of the cantilever. And there are other advantages. We bond the suspension to it so it doesn't change as you put pressure on it. It gives you better damping. The mass is lower. There's a whole litany of positive aspects to doing it that way.
Peter, you should let them know that your cartridge will track the Shure V15.5 test record at the highest modulation with no problem whatsoever. It's an important point.
I appreciate that, Harry. Thank you. Are you referring to the referring to the special Cicero I made or the Hyperion?
Both do it. My Cicero does it with no problem at all.
Yeah, it's just a great compromise design. You know, it's just got the best of a lot of things. And you know, there's a distinct advantage, you know, the moving coil structure. When you have an accident with a moving coil cartridge, you actually can rotate the armature, and there goes your azimuth alignment for the stylus. There goes your channel separation. Our design is, well, if you have an accident with it, you can actually grab the cantilever and rotate it 30 degrees, like, oh, it'll snap right back to where it was. There's no drift and there's no accidental internal damage. So it's there were a huge number of things going for it.
Very much like the ADC XLM from the 1960s.
That was a very, very good cartridge, wasn't it?
Fabulous.
Yeah, that was a fabulous cartridge.
Hey, Peter, when you're designing a cartridge, are you testing it on using actual test records like Harry mentioned, or are you just using regular vinyl, so to speak?
Oh no, I have a huge collection of test records, and then I have certain records that are really, really tough to play. You know, it's really interesting. Maybe I'll ask the audience, what would you think is the most difficult instrument for a cartridge to reproduce? Anyone have any idea?
I would say it's Ethel Merman in Gypsy.
I would think it'd be a harpsichord, wouldn't it?
Harpsichord is up there. There's actually an instrument that's
the violin.
Piano.
Yeah.
all difficult.
Cannon. How about a cannon?
Well, yeah, please. You know, one of my favorite demos was playing that 1812 record with an early strain gauge. And I watched the customer because when it hit the cannons, a whole tarn arm would lift up off the record and land on the label. It's absolutely my favorite, my favorite demo of all. We used to do that, Jeff, at Audio Experts. No, the most difficult instrument to reproduce, look at it with the scope, is a muted trumpet. That bad boy, look at it with a scope. That bad boy is a spike, is a spike. You take a record with not a muted trumpet in the background up front and hook up a scope and play that with a bunch of different cartridges and listen to it and go, oh my God, this thing can't track that waveform. It can't. It's literally a spike. The strain
Miles
gauge,
Davis record, Someday My Prince Will Come, is a good example of what you're describing.
Yep. If you want to find out how well a cartridge can track, play a loud muted trumpet. You'll be, oh man, I can't believe that. The strain gauge, by the way, will do a square wave. It's the only cartridge that'll play and reproduce a near perfect square wave. Again, because of the extreme speed, the low mass, the damping that's there, properly terminated, near perfectly terminated cantilever. So,
Peter, I'm going to
Yes.
say goodbye because I'm down to 9% and my wife is yelling supper's done. So
Bye, Dad. Trying to say bye.
talk to you tomorrow. Bye-bye, guys.
Hi, Shiloh.
Bye, Papa.
One wife's filled out, one wife's filled in.
3. I got 3 of them here.
Yeah.
beautiful family.
We want to go to Bruce Barber.
Well, I think Jonathan Skull has been waiting patiently.
John, it's
and-
Uncle John. Say, I love you,
So-
Uncle John.
Uncle John's going to talk.
Oh, going to be nice.
Hello.
I have a question for Peter.
But hold
Oh.
on, hold on. ahead,
Okay,
Jonathan.
so I just want to say, Peter, that I haven't seen you in a long while, and it's great to see you looking and sounding so well. I'd heard about your presentation about the cartridges, the energy, but I never heard anyone record it or explain it. And so tonight was very interesting for me because now I feel from your really well done presentation that I understand exactly what it is that you do. And I really respect your work. And I thank this group for letting me butt in. And it's a really great group. You seem to have terrific people. So keep it up, everybody. Peter, Kathleen is sending you her love, and I got to go over there now. So I'll see you guys later. Thanks for putting up with me.
Please tell her I said hello, would you?
Okay.
Guys, I'm heading out too. Getting overwhelmed. Peter, good to see you. Great to hear everything.
Good to see you, Matt. Take care.
Bye, everybody.
Okay, for my question now.
Sure, go ahead. And then we've got Bruce, Alan, and Bob waiting in line also. So
Nobody's
but go-
nobody's asked me about my antique analog device, by the way.
I was admiring it, if it makes you feel any better.
Okay.
Yes, Josh wanted to know if it worked.
Absolutely.
Oh, just before Bruce goes, we will get to the questions in the chat room. We guarantee that. So put stuff in the chat room and we will ask those eventually. Go ahead, Bruce.
Okay, well, you can take mine out of the chat room. Thank you, Mr. Ledermann. You've taught me a lot that I didn't know about phono cartridges for starts, and I love the story about the cactus needle. Those are great. But my question is just a bit of a hypothetical and asked with somewhat playfulness. If history had gone a little different and we had learned how to record sound, either, let's say, magnetic tape or even digitally prior to the phonograph, do you think we would have ever invented a phonograph? And I ask because when I look at it, I think what a marvelously put together but very strange machine.
I agree with you 100%. And I've never heard that question posed before to anyone. And it's a really wonderful question. You know, it's similar to saying if digital photography had been invented first, would they ever have done chemical photography? There is a visceral magic to analog, certainly with tape, but much more so with something you can fondle, like a record. You know, I've heard the analog made with, you know, if you want to get drunk, you take a shot of vodka. But if you really want to enjoy yourself, you decant a bottle of wine, and a fine wine, and you sip it slowly. that's analog. And I can't imagine that there aren't people who, realizing it would be possible, would not have really enjoyed it. I mean, when you consider what it is, it's this miniature sculpture that's fragile, it's delicate. You have to keep it scrupulously clean. You have this mechanical, seemingly archaic system that you try to tune as best as you can, get the best compromise. And when you play it, magic happens. You know, I own about 6 windups, and I make cartridges for cylinder players. And there is this joy when you go over to one of my windups and crank it up and put a 78 on it that no electronic system can equivocate. I think it would have been invented, and regardless of the size of the following, it would have been loved for its visceral nature. It's sort of like, you know, saying, do you want to be in love with a virtual woman or a real woman? Because the real women are hard to find.
Well, thank you. But, you know, the other thing was you talked about it for the first time I've ever heard. You've talked about analog sound in the terms that we usually talk about digital sound, with using jitter and so forth, which was interesting. Right.
It's the reality. And of course, you won't hear another cartridge manufacturer talk about the problems of how, quote, bad analog is. And that's the beauty of it. The beauty of it is that it is stupidly challenging. I mean, think about building a loudspeaker that, you know, is the best compromise of all the things that loudspeakers do wrong, or microphones. You know, there's this wonder and this beauty of doing the right combination of things. You know, when I worked at Bozak, I designed a loudspeaker, and Rudy came from the back building one day and over to the sound room, and he listened. I asked him to come over and listen to it. He listened politely for about 20 seconds, and he put on his little felt cap and went to leave the sound room. And he turned on his heel and he looked at me and he said, you know, he said, when you're designing a loudspeaker, there are 10 things you'd like to do. You're only going to get to do 3 of them. You'd better pick the right things. And then he turned on his heel and he left. And I couldn't tell if he dissed me or if he laid a lifetime of wisdom on me. It turned out he'd laid a lifetime of wisdom on me in a moment. And that's a real teacher. And, you know, this is true of cartridges, and loudspeakers and microphones. There is so much that can go wrong that when you get them to work pretty well, it's a joy beyond description. And I think that connects with your question. You know, do I think an analog system like vinyl would have been, as archaic as it is, would have been created? I think the answer is yes, because everything that, I mean, you look at nature, everything that can exist pretty much does, for a while until we wipe it out.
Good enough.
Oh, Peter, by the way, my 32-year-old daughter, who's a professional photographer, which basically means she works as a nanny and tries to make money in photography, she started out as using digital photography only, and now she shoots most of her stuff using film. And with that, we'll let Alan Chambers ask the next question.
Yes. With all the baggage, if I may use the term, that moving coils have, why do so many people still love them so much? Is it the way they're coloring music, or why are they still so in vogue?
You have to look at the history of it. You know, you have to look at what happened. You had moving magnet cartridges with replaceable styli. And then this whole new genre of cartridges was invented. This moving coil concept as being better than moving magnet, no replaceable styli, and it swept the market. The compliance was lower. You went from light tone arms to heavy tone arms. It just dominated the market. You know, people have asked me, well, if what you're doing is better, why don't other people do it? Well, Bang & Olufsen had extremely tight patents on it, number one. And number two, if you've been making moving coil cartridges for 20, 30, 40 years, what are you going to do? Change horses and say, by the way, everything I did back there was wrong? Well, that's business suicide. So hopefully that answers your question. It was protected, and it would be business suicide to switch horses.
One other thing I happen to be a pipe organ
Can you
freak.
speak up a little bit?
Yeah, I happen to be a pipe organ freak, which means I love all that energy from a large pipe organ down in the 16 to 20 hertz range. And for that, I notice numerous advantages in digital recording
Of course,
over analog.
of course.
One of which is at those low frequencies, when we're cutting a record, we want only lateral modulation with as little vertical as possible at those low frequencies.
Okay, so I wish Harry were still on, because one of the things that Harry said to me when we were talking a week ago about the strain gauge, he was making a comment about the low frequency performance of the strain gauge. And he said, I've never heard anything like it. The cello doesn't sound tubby. All the harmonics, you can hear the rosin on the bow, you can hear. Magnetic cartridges often have very poor damping at low frequencies, and they get tubby, and they muddy things up, and they color things. Our moving iron cartridges rather have extremely tight low end. So I totally understand what you're saying. I think you're attributing it to the wrong thing. If you heard a different technology of cartridge with your pipe organ records, assuming your system has good damping at those frequencies and tight control of the cones, I think you would hear something completely different.
Because I was talking more down in the 16 to 20 hertz range, far lower than any cello.
I understand what you're saying. What I'm saying is, if you measure most cartridges at the very low frequencies, they're incredibly nonlinear. There are a lot of resonances, reflections, and it makes them sound tubby.
Okay, thank you.
All right, we got Bob Grossman and then Bob Fennerin. So Bob Grossman first.
Okay. I've heard Peter's name mentioned for years, and it's absolute pleasure to hear you speak tonight and bring up so many important ideas. So I really want to thank you so much. I wanted to make a couple comments and then ask a couple questions. If there's too many to deal with, then just pass along. But in terms of your mentioning the muted trumpet, I would concur and agree that that is one of the most difficult challenges to discern, along with the timbre of many other instruments. My background is in classical music. I was a member of the Philadelphia Orchestra for 40 years before I retired last year. And even in live music, when you're listening to masterful players performing in live concert hall settings, it can be very difficult to distinguish the sounds of the trumpet, either muted or unmuted, occasionally from the range or the tessitura of oboes, which are a completely different double reed instrument. And as a bassoonist, I was just talking about this recently with a friend of mine who played the French horn. So in a composer like Brahms, masterful orchestration that would use the bassoon to play doubling bass lines, trading off melodic lines with the horns, and you just get these combinations of sounds. So you think about Ravel and the way he's orchestrated Bolero with the same theme, going through many variations, played individual instruments, doubles or triples, and eventually the whole choirs. And all of these things are just amazing to hear reproduced. And when I'm evaluating equipment, these are all sort of my litmus tests. And for people in the jazz realm, Gil Levin's orchestrations are just amazing. In particular, the works that he did with Miles Davis, who notoriously used the harmony mute so much for his distinguished playing. But my question to you is the designs of 78s and how that evolved into LP, and specifically when you mentioned elliptical versus the conical cartridge. Where is that role play in the different design and use of a mono cartridge for older records versus stereo records? Because the mono only has that one groove that, from what I understand, the information's more, should we say, vertical rather than horizontal in stereo, because you don't have to go side by side.
Mono is can be quite superior to stereo in terms of reproduction. It's an easier groove to track. We do make all of our magnetic cartridges are available as dual coil monos, which is very interesting, and I don't want to spend a lot of time talking about it, but it's a very interesting mono design. But mono can sound quite a bit better than stereo. Of course, when you make the primary recording, since you're not multi-miking, there are no phase errors, so there are no timing or timbre errors. So I wanted to point that out. Mono has some advantages, just puts you back farther in the hall. In terms of 78s, 78s were designed with a talc in the material. They were designed so the stylus wore out, not the record, which was, whoever thought of that was incredibly clever. So you don't really care so much about the stylus, you care about the record. Those are my two comments about mono 78s. And of course, there was an obvious evolution into microgroove where you took a lateral recording and made it independent to get stereo. The people who developed it and made it backward compatible were incredibly insightful and clever people. We owe them a great debt.
Quick question,
Who's next?
quick question, Peter, and then we'll get to Bob Fennerin. When you're playing a mono cartridge through a stereo preamp that doesn't have a mono switch, is there any detrimental effect to that?
Say that again. When you're playing a mono cartridge through a stereo. Okay, so our mono cartridges have two channels. They have two mono channels, and you hook it up like a stereo cartridge. Interestingly, there are very subtle differences between the channels. So when you play one of our dual coil monos, it adds a little bit of an ambience to a mono recording that wasn't there. So it is an artifact, but it's it's a pleasant artifact. I'd be the last person to say that artifacts are bad. I'm not going to throw out the baby with the bathwater. In fact, I have an invention that is based on artifacts that puts you into an alpha state in about 30 to 60 seconds, listening to almost any kind of music. I invented it 40 years ago, and I've never brought it to market. Tubes create artifacts, huge amounts of them, and they sound great to a lot of people. So I'm the last person to say that artifacts are bad. Our mono carts, they're dual coil monos. You hook them up like a stereo or a single channel if you want, and you play it through a stereo system. The effect is very, very pleasing.
Bob Fennerin, go ahead.
Yes, sir. Two questions. Number one, are all your cartridges with strain gauges? Or I notice you have a lot of different types in your catalog.
They're all moving iron, except for the strain gauge design.
Okay, which ones are the strain gauge design?
I make two different groups. I make what you would have to call an entry-level group. The strain gauge requires a specialized preamp because it doesn't use RAAA. So they're sold as a system, preamp and cartridge. I make an entry-level series, that is preamp and cartridge, 3 models, the 200, the 210, and the 230. The 230 is a full function preamp. Then I make a signature series. I make 5 different signature models. The strain gauges are different. The electronics are the best I can make. The strain gauges are the best I can make. And those are for people who want the best strain gauge cartridge you could get in the world, at least that I can make. The preamps have some unique features. Some of them, they have display features. They show tracking force per groove wall in real time, which is a fascinating display, especially when you have a non-sinusoidal waveform in the groove. It displays it, and it also can display record warp. So we have some very sophisticated, what are called signature series strain gauge models. But it's basically one strain gauge cartridge, although I do make the signature series, and all the rest of my products are moving iron.
Okay, one final question. I know you sell cartridges. Do you have a service to put them properly installed on the arm and the turntable?
We've done that for years. COVID certainly put a dent in that, but yes, we've had many customers show up and my engineers will mount and align cartridges for people. We've certainly done that over many, many years. You know, I've done and taught audio servicing for 50 years while I worked at other companies. and 30 years continuously now since I've left IBM.
Thank you. That's all I have to ask. Thank you for your information.
You're welcome. Thank you.
Bob Grossman, you want to get back on?
Yeah, with Peter's expertise on all of these groove modulations and so forth, when I listen, I have an extensive record collection. So when I listen to mono records from pre-1960 to the 1950s, I assume they were cut on a lathe that really set a mono groove, because that was the technology of that era. And then as they went into the 60s, and records were issued both ways, stereo, mono, and so were they cut in the different ways? Because even the old inner liner notes will say, do not use a mono cartridge with this stereo groove or you're going to wear it away. And the other aspect of my question is, so what is happening with the new reissues that are coming out by all of these acoustic sounds and Tone Poet premium labels, that they're reissuing the old jazz records in mono, but is it really a mono groove, or is it just a stereo being cut by a stereo lathe with a single signal? And so when we listen to those things, should we use the larger, wider grooved mono cartridge, or just stick with using a stereo stylus?
Okay, so larger stylus, the 1 mil stylus, was only used for a short period during 48 and a half of 49. So don't worry about anything other than a normal stylus.
Okay.
In terms of cutting a record with a stereo lathe with a mono signal, if you cut it with a stereo lathe, you're going to get a lateral cut only. The reason you can't cut a play, or there was that warning on early stereo records, was because a lot of people had old mono cartridges which had no vertical compliance. So since stereo records have vertical modulation, if you have no vertical movement with the stylus, you're going to rip the crap out of the record. So they were actually referring to really old mono cartridges that didn't need to have vertical compliance. They were just moving laterally.
Great. Thank you for clarifying that.
You're welcome.
Thanks, Bob. Miles, you asked a question in the chat room. Do you want to ask that live?
Well, I think Peter more or less answered it about 25 minutes ago, maybe. So I'll pass on that one. Thank you.
Thank you. Oh, there was a quick question here for you, Peter. One of the listeners wanted to know what your favorite cartridge is.
You know, I love the Hyperion, and I really like the Paua, and I really like the strain gauge. In my engineering listening room, I have on my VPI table, I have the Hyperion. Of course, I have a lot of VPI arms. One of the advantages, of course, in owning a VPI table is that I can have a lot of cartridges mounted up and swap between them. On the rear of my VPI table, I have a Schroeder reference SQ, and I have my strain gauge on there. I have two other tables that I absolutely love, and I have Hyperion on one and a strain gauge on the other, and that's what we bring to a show. There are certain recordings that you want to play with the Hyperion or a magnetic cartridge or the Paua or the Cicero, and others you want to play with the strain gauge. There's certain records you don't want to play with the strain gauge. There's not a lot of them, but there are certainly certain ones. You want a little bit of integration on certain recordings that are less than perfect. You want to smooth them out. Again, it's like a beautiful woman. You want to be 10 feet back and really admire her. But those are, I mean, I love the Paua. It's the sweetest of all of our line. I could listen to that, but the Hyperion really solved a major technical problem. It has incredible detail without making your fillings fall out when you turn it up. And that's a problem with a lot of magnetic cartridges, high-end nonlinearity. The Hyperion did an incredible job of lowering that dramatically. The strain gauge does it inherently because it's so ridiculously accurate. But those are the two cartridges that I would listen to. Other than my wind-up.
Out of those three, which is the most affordable?
Well, the Paua is 4K. It's $39.99. Bear in mind that when you talk about affordability, you have to think about time. We're the only company that rebuilds our cartridges for 20% or less. The Hyperion is rebuildable for 11%, the Paua for 13% repeatedly. So you can use the terms long-term value with the Soundsmith cartridge. You really can't use with another cartridge. When it wears out or you have an accident, you wind up with a new cartridge for a fraction of what you paid for it. So affordability, well, that's, affordability over a year or affordability over 5 years, or something you can put in your will and donate to someone or will to somebody because it has intrinsic value or resale value. Affordability is a broad term.
And the turnaround for rebuilding, like the Paua, is the same as the other?
Not at the moment, because I was very ill. And so a lot of my work is backed up. I tend to rebuild. I build all the high-end magnetic cartridges myself still, and I rebuild them.
Right. Oh, and since you were talking about VPI turn arms, which of the VPI arms that are currently available do you like the best?
I don't have any current arms. All the arms I have are some of the older metal arms.
So no 3D?
I don't have any of the 3D arms.
Any plans on picking one up? I think Harry probably give you a good price.
He might give me a good price, 10 over list, maybe. No, I don't need any at the moment. I have a ton of metal arms for my HRX, and we're going to be making a tone arm designed by Frank Schroeder called the Alto. Really brilliant design. Frank's one of the geniuses in the industry. So
here's another chat question. The energy heading back down the cantilever to the stylus, how is that measured?
It's measured by stylus jitter. One of the things that somebody almost touched on before, although it's not an absolute way of finding out, when you're dealing with an individual and times are going along pretty nicely, you're not really going to find out who they are. When times get rough, that's who you're going to find out who you're dealing with, either in yourself or in somebody else. And the same is true with the Phono Cartridge. When Mr. Grossman was mentioning orchestral passages, when you're a designer or you're trying to evaluate something as an audiophile, you really want to listen to a tough moment. And that's what you should be listening for. The strain gauge, like when I put on, let's say, the Firebird, I have, of course, the wonderful Mercury recording and the one that was made in the 80s. The incredible thing about that is there are moments of cacophony, and with a lesser cartridge, you get a moment of absolute mud because the stylus says, forget it, you want me to do what? It looks down this canyon and it's going, you want me to touch every one of those rocks down there without losing it. That's what you should listen for. When the strain gauge hits an incredibly complex moment, usually orchestral, it could be jazz, what you hear is all the instruments combed out. Nothing gets muddy, nothing gets distorted, the image doesn't shift. That tells you that the stylus is staying in intimate contact with the groove wall. So that's a good way for a non-technical person to evaluate a cartridge. What happens in a rough moment? That tells you exactly, to a reasonable extent, what's going on at the stylus groove interface.
All right, a couple more chat questions, then we'll get back to raised hands. I'm confused. Why is the tone arm excluded from the energy transfer? It seems if like all 100% of energy is reflected back within the cartridge itself, no transfer to tone arm or dissipation in cartridge body materials. Hope that made sense.
Okay, yeah, that's absolutely wrong. I have a lot of, and I apologize for not mentioning it. I already had talked too long, and as you gentlemen have witnessed, nobody likes to hear me talk more than me. I have a lot of drawings of tone arms, and a tone arm is, in a sense, the exact same thing as the cantilever is in the cartridge. It's just the cantilever is a miniature tone arm. So tone arms are huge in terms of storing energy, reflecting energy, bearing all the problems that I talk about within the cartridge. People are more familiar with those problems when they think about tone arms. So it's absolutely huge. and even the turntable. So, I'm not going to mention names or brands, but every once in a while I get really wowed, and I was wowed by a tone arm turntable combination with my strain gauge that I just didn't think it would make as much of a difference as it did. And I brought two of my engineers in and I said, what do you hear? And they went, holy mackerel. I went, all right, so I'm not just me having a good day. So yeah, the tone arm is super critical. The tone arm is really, really hard to make a good tone arm. Everything that applies to a cartridge applies to a tone arm. Young's modulus, bearing rigidity, reflectivity, energy storage, on and on and on. Now, mind you, a well-designed cartridge, and this is one of the things with our new DEMS ES models, they're designed to get the energy out of the cartridge, out of the moving system and into the body for the tone arm to get rid of. Another design of cartridge really doesn't get the energy out into the body, so it just reflects inside the cartridge. So that kind of a cartridge is going to sound the same no matter what tone arm you put it on. A cartridge that's designed to get the energy into the arm, that's more arm dependent. Can be a little harder to market, but it's the right way to do things.
Here's three questions that I'm going to ask at once because they're kind of related, and then we'll get to raised hands. Is there an average play hour use of cartridges for wear? Is it best to examine and look at the wear with a microscope? And what is the best way to clean a cartridge between plays and use?
Sure. Conical is about 500 hours, hyperelliptical 750, line contact 1,000. All of this depends on how well the cartridge is tracing and if you've got the anti-skating set correctly. Having serviced tens of thousands of cartridges, I can tell you that almost nobody has their anti-skating set correctly. Look on the website. We have a method developed by Frank Schroeder. It's perfect. First order perfect. And everyone I've told it to over the many years has come back and saying, wow, it just sounds better. It's like, well, yeah, well, Frank's a genius. Of course it sounds better. So of course, by the time you hear a problem, it's too late, but you want the anti-skating to be right so you get even wear, not just on the stylus, but on your records as well. Best way to look at a stylus, with a reflected light, microscope, turn it carefully and look for a flat. How much of a flat? Not a lot. So, it depends how picky you are.
Is there a picture of the wear that you could, that's accessible so someone knows what to look at?
I'm sorry, I don't have any good photos of stylus wear. There are some on the internet, but mind you, you're changing a knife edge into a flat, and when the flat gets too big, it starts chopping up the high frequencies in your vinyl. Not because it has a sharp leading edge instead of a rounded sharp edge. When you grind a flat, that leading edge is really, really, really sharp. It just chops up your vinyl.
And how much before that, how much magnification do you recommend to actually view the cartridge at?
Yeah, you want to be at about, for the stylus, you want to be at somewhere around 300 to 400, and then you've got to rotate it slowly and get the light, get a nice little LED focus light, and rotate it. When you get it just right, that flat spot will give you a reflection off the light and into the eyepiece of the microscope, and you get it just right. You go, oh, holy mackerel. And then you can look at one side and the other and go, all right, the anti-skating's not been right. I'm getting too much wear on one side or the other. In terms of cleaning, we recommend using blue tack on a quarter, and you buy it and it's the blue stuff, the putty, you smear it out thin on a quarter, about half the thickness of a quarter, put it on the platter, cue the stylus down 3-4 times into it, move the quarter off, do that every play. If that does not clear the stylus, then you can take a watercolor brush that has bristles about 1/8 of an inch in diameter, cut it down so they're 1/8 of an inch long, break the handle off of it. You've just got the bezel, use rubbing alcohol, isopropyl, any concentration, make the bristles not soaking wet and not just damp, and brush the stylus back to front, do it 4 or 5 times. Don't wet clean constantly. Epoxy that's used to hold styli in is hygroscopic. It absorbs moisture. Every time you use a solvent, moisture from the air condenses on it. The epoxy swells, the diamond doesn't, the cantilever often doesn't. Once you swell and let the epoxy grow and shrink a bunch of times, Elvis will leave the building. So that's your regimen for cleaning styli. Dry clean with blue tack, and every once in a while do a wet clean.
So a quick follow-up. would Stylast be a liquid that you would not recommend, or is
I
it
am not
okay?
going, I'm not allowed to comment on any current product that's made by another manufacturer. What I
Okay.
can tell you, and I'll say this carefully, is that elastomers are not compatible with all the liquids that are out there. I'll say it again.
All right,
Elastomers
so
are not.
I got it. Let me flip it around then. Is there some treatment for elastomers that makes them last longer, to prevent them from hardening?
No.
All right.
Less is more, I guess. Can we let Arnis go first with the raised hands, because he hasn't asked a question yet, and the other two hands already have.
And he just got out of the hospital.
There you go.
Peter, thank you very much for taking us on a journey into the micro world of the groove and the stylus. So very, very enlightening. My question is, what are your thoughts on the optical cartridges?
So again, this is somebody else's product. So I'm, part of my audio faith tradition is not to talk about anyone else's design. The best thing I can say is the devil is in the details. So with any cartridge of any design, any manufacturer, look at the channel separation. That's number one. That'll tell you a lot about the devil in the details. Any technology can be done wrong. So that's about all I can say. The optical cartridge is obviously not a new idea. Toshiba did it back in the 60s. In principle, it's something that functions. It could be made to be wonderful, but bear in mind what I'm saying. Any cartridge technology, strain gauge, magnetic, moving iron, moving magnet, moving coil, optical, anything can be done wrong.
Do all cartridge manufacturers show channel separation in their numbers?
Most, but not all.
And are they all calculated the same way?
Yes, you're typically looking at 1 kilohertz at a specific modulation level, correct.
So it's apples to apples in most cases?
Most cases, it's apples to apples, correct.
Okay, anything else, Arnis?
No, that's all, thank you.
All right, Alan Chambers.
Yeah, speaking of tone arms, have you encountered any effective straight line tracking tone arms?
Have I encountered any defective ones?
No, straight line tracking.
Yeah, any
really good ones.
Oh, really good ones. The Schroeder. I've not played with enough of them to make a comment. And again, I can't comment on current products. I'm very familiar with Frank's linear arm. It's a wonderful arm. I don't get to play with it. They don't let me out much. So I wish I could tell you I'd played with a lot of linear arms. I have not.
Well, that should eliminate any problem with and escape misadjustment.
Alan, you're done?
Yeah, thank you.
Okay, Alan Edelstein's next.
Since we're talking about cartridges, we're talking about art and science together. I had a friend once who I took a copy of a magazine called Hi-Fi Choice when they only tested one kind of product at a time. And this issue was about 60 cartridges. This is about 40 years ago. And in this case, they didn't just do it subjectively. They measured frequency response separation and a 1 kilohertz square wave that was at the bottom of each page. And my friend kept looking through it, couldn't see what the cartridge was, and stopped at a page and said, "I want that cartridge, I know what it sounds like." And I think he was primarily looking at the square wave, which sounds like the pulse test, at least something like the pulse test you were talking about from Bang & Olufsen. And I will add that my friend had previously modified Grado cartridges and measured the modifications, so he had some sense of what he was looking for. Any comments on that? Would you dare to pick a cartridge based on a square wave? I will say it was a flat square wave with only a cycle or two of ringing at 1 kilohertz.
You're probably not going to like my answer.
No, I'm just curious.
I had a gentleman who tried to improve my understanding of life for many years, and I'm sure it was like getting blood out of a stone. And he used to turn to me and say, you know, Peter, he said, it's not soap or water. And then he'd generally walk away from me after he said that.
Okay. A question about, you were talking about separation. Is it the amount of separation that's critical, or is it the shape of the separation curve? And what I'm sort of saying is, if the separation is relatively constant throughout, and many cartridges, it varies, especially at the frequency extremes. And yet
exactly, yeah. So yes, separation is a complex concept. You can have good separation in the mid-band and horrible separation at the extremes, or vice versa. And as I did mention, and I sort of glossed over it, I said separation can give you some information about the cartridge, not always will. So please follow the logic of what I said. I did briefly mention that if you over damp a moving coil cartridge, you'll get really good separation figures. Do you want to listen to it? No, you wouldn't take a Stradivarius and stuff a bunch of sponges inside the sound hole and play it and go, wow, I've gotten rid of all the ringing. No, you know, everything is again, it's not soap or water. It is just because something has a great separation curve across the spectrum doesn't mean they've solved the problem. It means they may have solved the problem. It's much more to it than any one thing. It's not soap or water. It's soap and water and a whole bunch of other things.
It's necessary, but not sufficient.
It's indicative, but it is not sufficient to tell the story by any means. Correct. You know, I mean, that's one of the beautiful things about audio. You've got to sit there and listen to it. You've got to sit there and say, that's music, or
But we do look for correlation between measurements in order to make the job easier.
Absolutely, absolutely. You know, it's like what, the 4 blind men feeling an elephant, and they each get a different description of what one's got the trunk, one's got the tail, one's got the feet.
Bob Fennerin, you want to jump in? You had another question?
Yes, I have one left field question. Sir, if I have a high quality cartridge and I'm playing an album and I have an extremely high volume out of my speakers, is there feedback to the cantilever and the cartridge from that?
Absolutely. Absolutely. There is always, at some level, the sound pressure is going directly into the tone arm and back into the cartridge and down the cantilever. There's sound pressure getting into the plinth, into the feet. Absolutely. If you're playing at a high sound pressure, you want to really have sorbethane feet under the turntable, a lot of them, and the right density. And if you're going to play at a high level, you may even want a complete dust cover that, again, is resting on sorbethane at the corners. So you're stopping the sound waves from getting into the turntable. It's
Okay,
a very good question.
That's what I do. I have a VPI and I have a nice cover for it. And I noticed when I didn't have the cover on, it sounded different. And I said, I'm 80 years old. My ears aren't what they used to be, you know. Thank you. Oh,
You're welcome.
One further comment. I really appreciate that you do not mention other companies' products. I appreciate that, the integrity of that.
Hey, Bob, what sounded better, the cover on or off?
When I play my Maggies at a high pressure level, the cover should be on. That's me, okay?
Right. Thank you.
Mhm.
Hey,
So,
Peter. Sorry, go ahead, Mark.
Oh, yeah, so I had a question. You said you'd hired new people. How long does it take to train people to do this kind of work? You said that the high-end stuff you still make by hand. So obviously you enjoy your work and love doing it. But just as a business, how long does it take to train people to do this?
It's a good question. It varies. You never know. If people have a proclivity towards art and focus, and they're more trainable. But it also depends on the individual. One woman I have who builds a lot of our cartridges, I hired her. She used to work in a 7-Eleven. You never know until you sit somebody down and you challenge them if they're capable of working at that scale. There's certainly there are tricks and techniques that you give to people, but I've told everyone that I've trained over the years who do cartridges, I've told them, look, with a particular task, it's going to start here. Unbelievably, ridiculously, stupidly impossible. Tomorrow, it's going to be ridiculously impossible. The day after, it's going to be very impossible. The next day, it's going to be impossible, sort of. The next day, it's going to be extremely hard. It's going to go to hard. It's going to go to sort of hard. It's going to go to not too bad. And then it's going to go, why didn't I do this the first time? It's like riding a bike. And once it's a learned skill under a microscope between your hand, your eye, and your brain, you learn techniques and you learn how to do it, and you pretty much don't forget. Who can learn it quickly and who can't? Crapshoot.
Hey, Peter, I bet that woman made a mean Slurpee.
With precision.
Exactly.
Yeah.
Wondering about your outlook for the future of analog in relation to LP hardware sales, brick and mortar versus online, how much of your product is sold online versus in store, stuff like that, wherever you want to go with it.
I don't really know. I don't have a good prognosis. Certainly the pandemic helped us in a sense, but it hurt us because we lost people. So we couldn't fill all the orders that we got. I think it made us more visible maybe than we were before. So that's certainly a plus from a business standpoint. I don't think vinyl is going away. It has this beauty to it. And we speak with a lot of people who've inherited systems from their parents, and they're going, well, I'm 40 or I'm 50 and I want this restored, and it was my father's or it was my grandfather's, and I love it. And I just got an email yesterday from a guy in France who bought one of our SMMC3 cartridges for his Bang & Olufsen. And he wrote me and he said, Mr. Ledermann, I just want you to know that my SMMC3 cartridge for my B&O system arrived and I installed it. He said, this was a system that belonged to my dad. My dad passed away recently. And he said, when I put the cartridge in and hooked everything up and I played it, I started weeping because it brought me back to my childhood. It's hard to express to you what an email like that does to me. There's something lovely about the invisible world that supports the visible. And the beauty of vinyl is that it's just right at the point of visibility, and yet this magic comes out. I don't see that going away. I see people needing more and more magic and wonder in their lives. And I think this fills a particular vacuum. How much do we sell online? We don't sell very much direct. We only sell rarely direct when people want to buy it directly from us. We tell people on our site, and when they call, to please go through our nearby dealer if they can. If they can't, then we sell it direct. We rarely do that. I don't know what percentage they sell through bricks and mortar and online because I don't track what they do. So I can't answer that for you.
Any new products coming out?
No, I'm just trying to, I'm trying to have a near life experience at this point in my life, as opposed to a near death experience. I just did that. Turns out I'm really crappy at dying.
That's good to know.
Not for want of trying. So right now it's called recover from COVID. You know, the business took a real hit, you know, in a lot of ways. And of course we were closed. Everyone got COVID. I was in the hospital and almost didn't make it. So, you know, we're just, you know, we ain't Amazon.com. Let me put it like that.
Has everybody recovered fully? No long-term health issues? I hope in your case also.
Well, I still have some long-term health issues. It's going to be 4 to 6 months before all the clots hopefully resolve to whatever degree. And it's very fatiguing, and they probably won't move anymore at this point. But you know, I've lost my sense of smell, a lot of brain fog, which I battle. So, but I think everyone else is pretty much recovered.
That's good to hear. Good to hear. Well, you weren't too fogged tonight. Thank you.
I used to be intelligent and good looking and funny, and it's all in the past now.
Yeah. Well, maybe you just had a lot of brain cells, so you've lost a few, but you still got more than the rest of us.
True.
Yeah. It's nice when the two marbles decide to talk to each other.
Those brain
Right.
cells were troublemakers anyway.
That's right. It's been great. Thank you very much, Peter.
Thank you, Peter.
Thank you all. Thank you all. It's been a pleasure. The questions were great, and I really appreciate all of you so much.
It was very educational as usual. And as somebody said before the meeting, like no matter how many times I talk to Peter, there's always something new that I pick up from him. And I think we all picked up something new tonight. So it was, thank you for doing this.
Well, it's my pleasure. I'm sorry I almost cacked last time, but I hope I made up for it this time.
Peter, do you think you'll be doing a show, if at all possible, in the future, and we can get to meet you in person?
I don't know the answer to that. You know, we're very challenged right now. We're trying to grow the company and hire new people, and you know, I'm considering another expansion for the business, and you know, it's I don't know my plans. We'll definitely do Munich next year in May. If for no other reason than just to see a lot of my friends, because as I said earlier on, they don't let me out much.
Any chance you'll be at Capital Audio Fest if that happens?
Hard to say. I think Harry wanted me to come and bring down the property values by just slumming and hanging around.
Well, you've got a lot of friends that will be at Capital Audio Fest, so we'd love to see you there.
Hey,
Well,
Peter, I could say you're always an addition to any room that you're in. I've always enjoyed your company, and it's great to see you. You do look well.
I thought you were referring to my circumference, that I'm a human bass trap. Isn't that what you were talking about, Mike?
Well, there's that too.
Loosely disguised, yes. Okay, right. No,
Right.
Peter, you're always a wonderful person to spend time with, whether it's audio or anything else.
I appreciate that. Thank you so much.
Peter, there's been some rumors going around that you might be moving your location. Is that anything you want to talk about?
Yeah, we're looking at a couple of locations now. I'm even tossing around the idea of opening up a retail store and putting part of our classic service division in there and selling records and accessories and classic gear that we've restored. You know, over the years, done it very quietly, but I'd love to restore classic gear and put together classic systems for people, you know, really high-end systems for a fraction of what they would spend elsewhere. So we're looking at formalizing that. We're looking at whether we can get some backers, either private or otherwise, and see if we can get a retail store going. You know, one of my motivations in Soundsmith is to mentor and to move people up, provide jobs for them, training. You know, at the end of the day, if somebody once asked me at another Zoom meeting, they said, what was my biggest accomplishment in the industry? And I said, it's really teaching people and allowing them to make a good living and support their families. That's certainly far more important than anything else in my book. And if I can expand Soundsmith and do that even at a larger scale, and take the people that I've taught and have them teach others, that would be a really good combination. I'm hoping if I do that, it'll give me time to work more on the Direct Grace project, my record project to rescue children in severe forms of slave labor, and take my 2 lathes up to my lab in Martha's Vineyard and get some music in there, some musicians, and do some direct-to-disc recordings and make more records, and move off to my retirement eventually, building some high-end cartridges. So, I've got some other designs. I'm sitting on about 150 inventions. I will never get to do but a fraction of them if I'm lucky. So it's the nature of, being an inventor. You learn to not be frustrated and just deal with the practical, which takes up 99% of your time.
Would that retail store be closer or further away from New York City area?
It will be in Westchester, but we've always been a destination location. I've had people drive, one guy drove 16 hours to get his stuff repaired each way.
Well, I hope you'll be doing tone arm and anti-skate setup as part of that business.
It will be. We'll be doing turntable setup. If we open that place, we'll be doing turntable setup because people want it. They want, not plug and play, but they also want to be taught how to do it. Take some of the mystery out of it, and they want to make sure things are right. I've taught a lot of people that work for me how to do it, and moving them off into a retail store makes some sense. So we'll see.
And maybe a DVD like for that kind of stuff as well.
We'll see. We'll see if I have time. Right now, I have to schedule bathroom breaks. Thank you all for your time again and your interest, and we really appreciate it. It's good to see all of you.